Hi, this is Mr. Frazier, and I'm doing a quick review of 2-1 notes that they took in class. They copied all these notes down. I have them also written as a picture. This will go relatively fast, so you can pause it, rewind it, replay it. They have to know what function notation is, and that's when they use f of x or f of whatever, and whatever the variable is also what goes in the parentheses. This is called function notation. They have to pay attention to units when dealing with independent and dependent quantities. Independent quantity is always x. The dependent quantity is always the expression or the problem. Okay? Then we deal with domains and ranges. Okay? Understanding that domain is all of your independent variables, and range are all of your dependents, meaning your outputs, your f of x or your answer. And your inputs or independents or x or variable or what you're plugging in are all the same meaning. So when we look at a problem, you have f of x of 3x plus 7. This is in function notation. Okay. That means whenever you plug a number in for x, you plug it in for x. Okay. The second part of the problem is where I start. So this tells me where I'm starting at 7. And this is the rate of change, which is the number in front of x. Okay. Slope or first difference, which are similar. And then unit rate is making sure that you have a denominator of 1. So that means if it's 4 over 5, you'd have 0.2 over 1 is the unit rate. Okay. You'd actually do the division and put it over 1. Alright, solving equations. This is a review. This is why I'm going relatively quick. Remember, you have to isolate the number and the variable by itself. So that means you minus 2 from both sides. You're left with 7x equals negative 14. You would then divide by 7 because they're opposites. This is multiplied by 7. So you divide by 7 and you get x equals negative 2. In this problem, you have to remember to distribute, which means to multiply more than once. So this is 4 times x, which is 4x, plus 4 times negative 7, which is negative 28, plus 12 equals 20. Combining like terms, which would be the negative 28 and the positive 12, because they don't have variables. When I combine them, I get negative 16. Then I have to get rid of the negative 16 by adding 16, which gives me 4x equals 36. Then I would divide both sides by 4 and gives me x equals 9. Okay. We get to the second page where all the variables must be on one side and all the numbers on the other. Doesn't matter which one I move. No, it does not. But I always move the smaller x so that my number in front of x is always positive. That's what I do. You can do it any way you wish. So if I move this over, it becomes a negative 9x. Combine like terms, which gives me 5x. I move the negative 13 to the other side, which becomes positive 13. Add combine like terms is 14. 5x equals 14. I get rid of the 5 by dividing by 5, and I get x equals 14 over 5. This is an okay answer. You may change it to a decimal if you want. I would say leave it as a fraction. When you have problems that are fraction and they're already set up, you can cross multiply. If this was not a fraction, you could put a 1 under it, make it a fraction, and cross multiply. So that means I do 5 times x, which is 5x, 5 times 2, which is 10, 6 times 2, which is 12. So the cross products are equal to each other. Next would be moving the 10, so in minus 10. 12 minus 10 is 2. Last but not least would be dividing both sides by 5, which gives you x equals 2 over 5. Okay. Last but not least, we're talking about the f of x and some OR problems. Okay. And they say for this f of 10, which means you put 10 in, 3 times 10 is 30, plus 7 is 37. So the f of 10 equals 37. Alright, and that is a quick, brief review over problem solving and 2-1.